So before I get started, let me talk a little bit about the previous two speakers and their topics. So I've been involved in the IETF since, 28 years now. And I've written 60 RFCs. I'm one of those people who does that. And of course, we have a lot of work going on of different kinds. In the IETF, when we have remote participation, like you might have with a, what do you call it, a hub? Remote hub, which 2 weeks from now, NIC.CR will be having a remote hub here. What I see as a working group chair is that I'm sitting at a table like that. I have a speaker giving a talk like we're having here, and we have another screen where we have the remote participant, and I can see that there is a remote participant that wants to say something, wants to give a talk, wants to get involved. And so we actually work with that very closely. And I would encourage you to participate remotely if you can, either just as an individual or through the remote hub capability. The fellowships that we do, that ISOC does, to send people to IETF meetings, what they do is they hook the person up with an IETF mentor. So at this particular meeting, I will be mentoring a person from NIC.CR, from Glen Peace, and a woman from, Cauda University in Bogota. Cauca. I'm sorry, my pronunciation is terrible. But so we have important participation from Latin America, and we work to help people become involved. As to your question of IPv4 being simple and IPv6 being hard, I can tell you a little bit of personal experience right now. I'm in the process of working with New Tribes Mission, which is a Christian mission organization, to deploy IPv6 throughout their internal network. They have 5 different sites, and they have different things going on in different places. Now, when you deploy IPv4, one of the first things you have to ask is, so how many devices do I have here? Am I going to put a /28 or a /27? How many addresses do I have? I'm going to parcel them out. What can I get from my ISP? Oh my goodness, I've got 1,000 people and I've got 200 addresses. What am I going to do? With IPv6, we have the exact opposite problem. In a single LAN, we will have 2 to the 64th addresses. So we have enough addresses for the sand on the seashore. And that's in every LAN, all the way along. So I don't have to think about, okay, do I have 2 people here, or is it 3? How many addresses do I have to allocate? It's just not a question. So literally what I'm doing in New Tribes is going through each VLAN that they have and saying, okay, it needs a number. How am I going to identify that so it's useful and understandable for the network operators, and that they can then deploy what they need to do and manage it well. And literally, I'm putting a prefix on each VLAN. I'm inserting some routing commands. I'm updating a firewall, and then the next question really is the applications. Is the application capable of using IPv6, and what do I need to do that? So a DNS name and that kind of thing. Compared to IPv4, IPv6 is really easy. It's not complex. So I think when people are talking about IPv6 complexity, what they're really talking about is their own lack of familiarity. They're not comfortable with it. And when you work through it, you become comfortable. It happens. So I think you really have an opportunity to explore and to experiment and then to move forward. It's not as hard as it might look. But okay, with that, let me okay. So now I'm going into the presentation, what I've prepared. IPv6 came out of a discovery. What did we do here? Okay, now I see where you were having problem with Guillermo. Okay, so in 1990, we were having a meeting in Vancouver, and a statistician by the name of Frank Selensky came out and said, you guys have a problem. You're allocating addresses too rapidly. By 1995, you will have, if you continue in the direction you're going, you will have completely run through the IPv4 address space. And we said, oh no, that's a bad thing. We don't want to do that. So we started out saying, let's figure out how to allocate addresses better, do a better job, which CIDR addressing. We asked for people that had addresses they weren't using to please give them back. And we came up with network address translation, which turned out to be a very big win. But we also, even with address translation in 1990, we knew that we would run out of addresses eventually. And it is just, there are more people in the world than there are address space in IPv4. We had to run out of addresses eventually. It's a finite resource. And so we started experimenting. We asked for different alternatives. And the one that was ultimately chosen was IPv6. There were actually several different proposals put on the table. Now, in 2006, ICANN turned around and said, okay, we seem to be having good success with IPv6. Let's put together a policy for allocating address space. And once they did that, you can see that allocations from IANA started out moving along quite well. Now, then exhaustion, what does exhaustion do? How does that work? Guillermo talked a little bit about when the different exhaustion events happened. And when he talks about that, okay, what he's saying is that the amount of address space available to a given RIR went below 1/8. So they were really parsing out just little bits. And you can see at this point that they're all in their final phase of only allocating to new entrants. And he actually had this slide. I think it's interesting that we duplicated there. So Latin America is doing quite well, but each of the regions of the world has a large number of service providers and companies and whatever that are announcing IPv6 address space in BGP. Now, the difference between 20% and 100% or 37% and 100%, the question there really is what company or what kind of company. The companies that are not deploying rapidly right now are at the edge. They are mom and pop groceries and this kind of thing, universities. But the ISPs have pretty much done so across the board. Now, worldwide, when I look at traffic growth, I can go through each of the countries and say what Google, what APNet, what Akamai is measuring as far as traffic in their particular area. And so you can see that in 2012, when this map starts, there was relatively little IPv6 traffic in the world at all. And that has grown over time. Now in 2014, the Belgian government came to the major ISP in Belgium and said, we have a problem with lawful intercept. We want to be able to identify every user or every subscriber that sends traffic for legal purposes, for forensic purposes. And so you cannot use a technology like carrier-grade NAT that multiplexes addresses. And so the Belgium Telecom said, fine, what we're going to do is we're going to deploy IPv6 and we'll see how well that works. And when they did so, they discovered that all of the end users were quite ready to use it. Your Windows machine, your Apple machine, your Linux machine has been using IPv6 for a long time. And most of the important applications like mail and the web have been using it. So they found that if they just made it go through the ISP and actually connect into the residential networks, suddenly everything worked. And so Belgium right now, about half of the traffic that Google sees in Belgium is IPv6 traffic. And why 50%? Why not 100%? Well, there's some randomness in the way the application decides how it's going to do it. It flips a coin and says, let's do this. And so half the time it chooses IPv6. Now the United States, I've had a lot of people that I've talked to say, well, when you do it in the United States, I'll think about doing it here. Well, United States, traffic is about 35% IPv6. So we're doing it in the United States. And you can see there's quite a number of other countries that are in the process of that as well. Now, something that I find interesting, this information all came from a report that ISOC produced in April. And in April, there were 37 countries that Google said that traffic coming into Google was at least 5% IPv6. I checked it Sunday, on the plane coming down here. And it was 41 countries that Google was saying that 5% of their traffic or more was IPv6. And one of the most recent ones is Uruguay. So Uruguay really just crossed that line in the last week or two. So it's interesting to watch the countries come on, because each of them is. Now in Latin America, and Guillermo talked about this, I have some differing measurements. Now this is Google, and looking at requests coming into Google. Are they using V6? Are they using V4? And you can see that there's several countries that are above the 5% level. Akamai reporting on exactly the same set of countries. This is the traffic level that they produce. So for Google, it's I got a request. I opened a connection, I sent in a thing, and I'm going to get a page back as a response. With Akamai, I'm caching and forwarding sessions using TCP. So these are really traffic volumes. And you can see that they're moving right along. One that I find interesting is Trinidad and Tobago. Now, Trinidad is not a big place. It's not a large number of users. But, and so in terms of total internet traffic, it's a drop in the bucket. But in terms of percentages there, what they find is that most of the users that are accessing information on the net go to Akamai, they go to Google, they go to Netflix, they go to Facebook, and those are all, they use IPv6 a lot. So Trinidad and Tobago, we're seeing large amounts of traffic using IPv6. Just a small island state, but it's kind of being a leader in its own way. Now, one of the questions that one has to ask is, okay, so with the end of IPv4, does that mean we're looking at the end of the industry? What happens next? And so a great example is actually a company that's in India. They're in the process of deploying a mobile network and a fixed network across country, across India. They started in 2011. So they went to APNet and said, please give me my large volume of IPv4 address space so that I can access these billion people, put them all on the net. And they got 1,024 addresses. And what do I do? It was just crazy. So, well, they had to purchase address space, and yes, one can do that. They purchased address space, but they also then changed and said, okay, what I can get is for every individual address that's in the IPv4 address space, I can actually get an entire LAN subnet with 2 to the 64th addresses in it, and deploy them, throughout. So they did. They got a really large number of IPv6 prefixes, each containing many addresses. And at this point, they represent about 20% of India's total traffic with IPv6. Internally, they say that IPv6 represents 90% of their traffic. Why is that? Well, it's being driven by where people go. They go to Google, they go to Akamai, they go to Facebook, they go to the big services, and those services within the Reliance JIO network only offer their traffic using IPv6. They don't do IPv4. And voila, we've got now lots of IPv6 traffic there. Okay, so does it actually work to have a company with a small amount of v4 address space and a large amount of v6? JIO would say yes, works quite well. Now there's an interesting study that has been done by LACNIC looking at address space and how it's used by applications. And now with IPv4, we each have a residential gateway connecting to our ISP, and it does network address translation. Companies quite often will have translation between them and their upstream. And it's not uncommon to have translation at other points in the network. So what LACNIC asked was, could I put an ad in a web page that will go do a test and just ask some system off on the other side of the network, what address do you see me using? And of course they know what address they think they're using, and it's the same or it's different. And what they found was with IPv4, 94% of sessions were through translation, somewhere or another, which has limitations, as I mentioned, for legal purposes, for forensic purposes. It also limits the ability to use location-based advertising and location-based services in the network. If I can't say who the subscriber is, I don't know where they are. And that limits commercial abilities, okay? So the question LACNIC was asking is, am I going to have the same problem in IPv6? What they found was that 0.6% of the IPv6 sessions were going through translation. 99+% of the sessions that were tested in this study were the address was the same at either end, which supports the lawful intercept requirement, supports the commercial location-based services requirement, supports the different requirements that one has. So I thought this was a very interesting study. Now, I had to read it in translation. You can just read it. You might enjoy going and taking a look at that. What is the future? Well, the graphic that I'm showing here is a slide from Mythic Beasts, which is a hosting service, a company in the United Kingdom. What they have concluded is in their hosting service, they will rent you an IPv4 address, but they'll give you IPv6 for free because it doesn't cost them anything. So they can just do it. IPv4 addresses from a sale perspective are what we call a speculative asset. It's an asset that has value right now because I can sell it right now. But at the point where we actually cross the line and the predominance of users are on IPv6, it loses its value. So from a financial perspective, IPv4 addresses have value now. They don't particularly have value in the future. And we're seeing services that charge accordingly. Okay, so I see a change coming. Microsoft is one of several companies that have said, this is just crazy. I have to run IPv6 because I have that much going on in my company. And it seems very strange to run both IPv4 and IPv6. Is there a way I can turn IPv4 off? And so they started that actually a couple or 3 years ago, and are moving along that path. They've had some things that didn't work, and they've had to adjust for that. But it has often meant that they've gone back to their own operating system, to Windows, and said, how can I fix that? And moved things in that direction. So for them, they're saying that turning off IPv4 means that they're not tied to the IPv4 depletion and oversubscription problems. They don't have the multiplexing of address space. They don't have the errors that NATs introduce. And it means that they, as a company, can concentrate on innovation. And these are their words in their blog. Okay, they can concentrate on what they do well, rather than racking their brains and saying, how can I make it work? T-Mobile, if I look at my telephone and ask what IP addresses it uses, it doesn't have an IPv4 address on it. T-Mobile only uses IPv6. LinkedIn is moving in that direction. Facebook is in that place internally. So we're looking at enterprises, we're looking at data center operators, we're looking at ISPs, we're looking at mobile, and people are saying it's just simpler to do it with IPv6. Let's move in that direction. Now, the big question, I suppose, is residential and enterprise. What happens with those? And let me give you a way to think about the statistics that we all see and we all talk about from time to time. Now, if I can count IPv6 accesses to content, and so in Belgium, half of the accesses coming into Google used IPv6. APNIC is saying upwards of 70%. If I look at various countries, and I can actually count IPv6 accesses to content, think about what has happened there. What has happened is that a user talked to his router, talked to his ISP, went to some other ISP and across the network to a data center and talking to some cloud server or something like that. And IPv6 worked at every point along the way. There was no point at which, oh, it doesn't work here, so we'll just stop that session. So when I say North America, the Americas includes you, 32% of systems are IPv6 capable. APNIC is saying that, out of some really large number of samples. And we can run a session end to end. It means that it worked in the laptop, worked in the residential router, worked in the ISP, worked in the other ISP, worked all the way through. So this tells you something about the growth and the development of IPv6 deployment. And then there's mobile wireless. Mobile wireless is actually moving very rapidly in the direction of being V6 only. The reason being that they have a cost driver. That is, for an APN, for the ability for a handset to talk to the network. You pay for an IPv4 APN, and you pay separately for an IPv6 APN. So they have a monetary reason to say, I want to turn that other one off. And like I say, my telephone, T-Mobile, has literally done that. And then we've got a number of companies in the United States, in Europe, in India, and various places that are very strongly moving in that direction. Now, I mentioned that you can actually buy IPv4 address space. And that made the news recently. MIT, the Massachusetts Institute of Technology, realized that it was not using more than half of the IPv4 address space that it was allocated in the 1970s. And so they said, well, let's turn that into money and use the money for our IPv6 deployment. Amazon said, I'll spend money. And so MIT actually sold a /9 out of its /8 to Amazon and is supporting Amazon's business in that way. Now, what we've seen, and this from, if IPv4 addresses were real estate, this would be a real estate broker that is, talking about that. So they have reported basically linear growth in the sale of IPv4 address space until LACNIC ran out. And about the time LACNIC ran out, all of a sudden it went level. And reason being, as much as anything, that, and you're making these slides available, right? So, okay, so I see people taking pictures. That's okay, but we'll make the slides available. So the demand is actually already dropping for sale of IPv4 address space. Something else, if I look at the price per address, when Microsoft bought address space very famously from Nortel, it bought it at $11 an address. And there have been various things along the way. Well, that has progressed over time to a stable value. And this particular company is saying what it expects to see next is that the address cost will increase until about the beginning of 2019. And at that point, IPv6 will have enough of a foothold that the demand will actually drop off for IPv4 address space and the price will go down. So when I talk about IPv4 being a speculative market, this is the guy who's trying to sell it and, can I please make the price high, saying it's going to go down. And, so I've actually really talked about this already. But, so this is from that same article and kind of the growth of the address. So now with that, actually, I want you to think fairly seriously about IPv6 deployment. It's not that hard. I'm doing it in a network that is not mine. It's not something that I've been thinking about for 1,000 years. It's something that I'm able to walk in and say, here's a VLAN, here's a VLAN, here's a VLAN. Let's put an address space on that. It's not that hard. And it winds up, Microsoft is saying, as they do it through their company, that it reduces their costs. T-Mobile is saying, as it goes through them, it reduces their costs. That they really want to move in the direction of reducing costs. And so the new news, the important thing here is that there's enough content out there, there's enough accessible material, there's enough capability and proven products that this is actually working reasonably well now, and we can move forward. So, if you're in the position of saying, I've got a lot of IPv4 address space and life is good, I don't have to think about it, that's a resource and you're not using it. You can actually use it to fund the deployment, which you're going to need anyway. So you have the opportunity. Now, I say here that IPv6 deployment is not trivial. You do have to think about it. It takes time. You have to look at your applications. You might have to upgrade your routers and things like that. So it's not something that you just walk in and say, okay, I'm on my way. But on the other hand, it's something that can be done. So now with that, I'm done. These are my comments. And let me throw it open to questions.
Sí. Bueno, gracias por las láminas, porque en realidad de la anterior lámina pues me desayuné con que estábamos en Bolivia, otra vuelta, que estábamos en el 4%.
Usar palabras fáciles porque me desayuné, va a ser difícil.
Bueno, fue una sorpresa para mí que Bolivia esté en el 4%, un poquito más en el uso, en el despliegue, pero ahora viendo la lámina es que veo que realmente la cantidad de usuarios es muy baja. Es decir, es como que tenemos ahorita un Mercedes que nadie lo sabe usar todavía, pero ya está desplegado. Eso entiendo porque la cantidad de usuarios en Bolivia, no somos más que 10 millones, 11 millones de pobladores, y de esos creo que menos del 50% todavía, y menos aún, tiene penetración de Internet. Me aclaro muy bien esto. La otra que es importante es que nosotros como universidad hemos hecho desde casi 10 esfuerzos para entrar a los ISPs. De hecho, Six Deploy con Jordi Palé lo trajimos alguna vez, estuvimos dando seminarios y esa vez tratamos de convencer un poco a los proveedores técnicos de que esto era, de IPv6 era el siguiente paso bien importante. Con solo pequeñas demostraciones que hicimos de eliminar el broadcast, el protocolo ARP, y digamos bajar la entropía del planeta. Con esto pues se puede de alguna manera también convencer, pero no hemos tenido mucho éxito como habíamos pensado. Por eso que decía también en la anterior intervención de que falta el otro componente de arriba, de que juntos, con conveniencia mutua, podemos trabajar, universidades con LACNI, para poder hacer más convencimiento a los ISPs para que den ese paso. Básicamente era eso lo que había comentado.
Okay, so anybody else?
Bueno, thank you, Fred.